Why does the Leaning Tower of Pisa lean? And how can modern engineering stabilize a falling shallow foundation? This is the story of why the Leaning Tower of Pisa tilted. Let's investigate the cause using Terzaghis bearing capacity theory. Every building needs a foundation to transfer its weight safely into the ground. The Leaning Tower of Pisa was built in 1173 on a shallow foundation only about 3 meters deep. The tower weighed around 14,500 tons and was built on soft clay soil. Because the soil was too weak, the foundation could not fully support the tower, causing it to settle and eventually lean. Let's see what happened under the foundation. At first, the tower stood straight on layers of sand and soft clay. The tower's weight was spread evenly across the foundation, so the ground sank evenly and the tower stayed stable. As the tower got taller, the soft clay on the south side sank faster than the north side. This made one side of the foundation sink more than the other. Because of this, the tower started to lean. The foundation did not break, but the ground could no longer support the tower evenly. As one side of the ground kept sinking, the tower started to lean. This put more weight on the weak soil, making it sink even more. As a result, the tower leaned further over time. Terzaghis equation. Terzaghis equation helps explain why the tower started to lean. The soil was too weak, the foundation was too shallow, and the groundwater made the soil even weaker. The foundation was also too small to spread the tower's weight. Because of this, the ground could not support the tower properly. The original builders assumed the ground was strong and uniform. In reality, the site consisted of soft marine clay with a high groundwater table. The shallow foundation never reached the stronger, dense sand layer beneath. Rapid construction also trapped excess pore water pressure inside the clay. In simple terms, they designed the tower as though it were standing on solid rock when it was actually built on a giant sponge. Our solution is to install piles and make the foundation bigger. The piles transfer the tower's weight to stronger soil deeper underground. A larger foundation spreads the weight over a bigger area. This reduces pressure on the weak soil and helps keep the tower stable. Our forensic investigation concludes that the Leaning Tower of Pisa did not fail because of weak construction. Instead, it experienced a bearing capacity failure caused by shallow foundations, highly compressible clay, and a high groundwater table. Terzaghis bearing capacity theory accurately explains the mechanism behind the settlement. Through controlled under-excavation, engineers successfully restored stability while preserving one of the world's most iconic landmarks. This case reminds us that every successful structure begins with understanding the ground beneath it. Do pick.